So our next topic is your equipotential surfaces, right? So see, what is equipotential surfaces? So basically, as per the topic, you can see equipotential surface is nothing but a surface in which at all points the potential is same, right? The electric potential remains the same. If you need to define that electric potential, means equipotential surface, right? Equipotential surface. Fine. We just need to define this. So how will you define this equipotential surface? So I guess you can write, right? I don't need to write this. It takes a lot of time. So you can just write. It is a kind of surface in which at all the points, right? At all, I am repeating again. At all the points, the potential are same. Means the potential never changes. Whatever point you will take that on that surface, right? The potential difference will be same. Fine. So if I need to draw a diagram, means you must be thinking how it looks. Simple. See, it looks like something like this. If I take a surface like this, so on this surface, the electric field always comes perpendicular to it. That is the interesting thing. Whenever the electric field comes perpendicular to it, right? That surface automatically becomes equipotential surface. So simple thing. Fine. So equipotential surface nothing but a surface on which at all points the potential difference or the electric potential are same. Fine. Very simple. You can just write by yourself this definition. Or shall I write here? I don't think so, right? It's very simple to know. Now see, or if I ask you in at equipotential surface, right, what will the work done by a charge? What will be the work done by charge particles? Guess? Yeah, 0. If the potential is same at each point, right, so potential difference must be 0. Like I have shown you that in a last class, that WAB, if you can relate WAB equal to WB minus WA. Remember, WAB equal to WB minus WA, and you know work done is nothing but potential, right? Electric potential. So I can just write this as VB minus VA. So we know these two again I'm telling you, at equipotential surface I am discussing, right? VB and VA both will be what? Same. So if I consider this VA is somewhere here and VB is somewhere here, so in both the cases the value of VA and VB will be same. Like if I take VA as 10 volt, then VB 10 volt, then VA will also be how much? 10 volt only. So if you subtract 10 minus 10, how much you will get? 0. So remember, on a equipotential, on a equipotential surface, right? On a equipotential surface, right, the potential difference or the net work done, right, by a charge particle or a charge particle will be equal to 0. Fine. The name itself say that equipotential means equal potential at all points. Equipotential means what? Nothing but equal potential at all the points of the surface. Is it clear? आ रहा है बात समझ सबको? Hopefully. ठीक है? I repeat again. If you have any question, please ask. Feel free to ask. है ना? पूछोगे नहीं, doubts clear नहीं होगा. ठीक है? So now see, let's move to next topic. That is the relation between. Next topic will be relation between electric field and electric potential. So this can be formed only on a equipotential surface, right? We will find with the help of equipotential surface. Okay. So let's draw a diagram first. So see the diagram. Let us take some curved lines of equipotential surface. Fine. Let's take, this is the equipotential surface, right? On this I just draw a coaxial line. Let's say this is S. Fine. This is S, a surface which is going coaxially. Now let's take at this point, right, plus q charge is here. At this point plus q charge is there, and this point is, let's say, as point P, and electric field will be perpendicular to this, something like this. Fine. So it will make some angle theta. It will make some angle theta here, right? So it will make some angle theta, right? So it will cover some distance here. Let from this point P, it covers distance of twice r, or let's say dr. Much easy. Small distance dr. Fine. Small distance dr. So it has traveled for small distance dr. So what will write? What will write here? So I am just dictating. Please try to write that, right? You write let a small test charge, or let a small test charge plus q at point P, small test charge plus q at point P, move through a distance dr. Move through a distance dr. It is moved by from a distance dr. Fine. From one equipotential surface to the other, from one point to the other, right? From this point to this point it will go, like from this point it will go to this point, from one equipotential surface to the other. Fine. The electric field E at P, the electric field E at P will be perpendicular to a surface, right? Will be perpendicular to the surface. Is it clear? So now what will be the work done on this field? So therefore work done by electric field, work done by electric field on the test charge, that is this charge plus q charge, right? How much will get? Test charge will be how much? Work done is nothing but what? Work done is nothing but what will get? Work done is nothing but q dV. Now you can guess what is dV. dV is the small potential at this surface. I have considered this small dV, means dV as the small potential on this surface, means which is everywhere. Fine. Now you must thinking why this q have came here, means q is all okay, fine, but why this minus have came? Since it is plus, why this have came? So the answer is this minus is there because if it will travel more, the what will happen? The work done will what? Will decrease, right? It will go automatically like this from this here. So see, so what will happen? The potential will what? Decrease basically. The more it will travel distance, the potential will what? Decrease. Fine. Why it will decrease? See, if the energy, see, like if I say the more I will walk, right? The more I will walk, what will happen? The more I will lose energy, and then more I lose energy, right? Then there is a chances that I will do less work comparatively, isn't it? Like in the morning, if I consider, in the morning a person can work for 5 hours or 2 hours, right? Fine, let's say for 5 hours, right, from morning. So will he able to work 5 hours from evening also? Do you think? No. You also, if I say after going from college, if I ask you study for 6 hours, study for 5 hours, can you study? No, because you are already being tired, you have already exhausted your energy. आप लोगों का एनर्जी ऑलरेडी खत्म हो चुका है. सो वर्क करने का कैपेसिटी क्या हो चुका है? बहुत ही कम हो चुका है आपका, है ना. जितना आगे जाओगे क्या होगा? आपका पोटेंशियल उतना ही कमेगा. कमेगा मतलब क्या है? नेगेटिव. दिस चार्ज मस्ट बी, दिस फिक्स q dv must be what? Negative. Is it okay? Now after that, but we know what we know, but work done is given by, but work W equal to F dot dr. This must happen. Force into displacement. If I consider this point, this at this point, right? If I consider this point, means on a equipotential surface, right? Normally we have taken out the work equal to in terms of electric field. The work that is done by the electric field. This work minus q dv is done by which term? Electric field. Now there will be another natural work done on this charge, right? So that is given by what? F dot dr. So now what is the value of force in terms of electric field? What is the value of force in terms of electric field? We have already done in chapter 1, that is what? Q into E, QE, right? F equal to what? Q into E. Remember or not? Because electric field was nothing but, what was the value of electric field? F by Q, electric field strength. If you remember, electric field strength was nothing but force on a charged particle, right? Is it clear? So if you solve this, what will you get here? EQ is equal to F, or you can say QE, whatever I have written here, right? So you will get as QE. In terms of F, I can write QE, fine, dot dr. Let's say this is displacement, both are. Now since it is a dot product, right? Since it is a dot product, we must convert in terms of magnitude. What will you get? QE dr cos of theta. That is there, you can see theta is there or not? Or you can add here, where theta is the angle between what? E and dr. Fine. Theta is the angle between E and dr. Now if I consider this equation, let's say 1 and this is 2. If I compare 1 and 2, see, both in both the cases work is done. So if I compare from 1 and 2, what you will get here? This must be equal to this, because work is common in both the equation. Work is common in both the equation. So I'll get minus Q dV is equal to QE dr cos of theta. Fine. So this Q will go, isn't it? This Q will go. So what I will get here? Just tell me what I get here. Minus dV by dr is equal to E cos of theta, isn't it? Minus E cos of theta. Now tell me, what will be the value of theta here? What will be the value of theta here? Value of theta, can you guess? So since theta is very small, right? Since, see, this theta is very small. In the diagram you can see it is very large, but in a practical, right, in a practical manner, this theta is very small. Very small means what? Equal to, since theta is approximately equal to 0, so what will get? Cos theta is equal to how much? 1, because cos 0 is how much? Cos 0 is how much? 1. So we'll get as, therefore, minus dV by dr is equal to E. So this is your relationship between, this is the relationship between electric field and what? This is R, I'm again repeating, this is R, don't get confused, and this is V. Relationship between electric potential and electric field. Fine. This is the relationship between electric field and electric potential. Is it okay to everyone? So this is your relation. Sometimes they used to ask this, deduce the relationship or derive the relationship between electric field and electric potential. Fine, on a equipotential surface. So this will be your derivation for 2 marks. Very simple, I guess. Fine. So 2 marks is very important. Always remember, in your exam, 3 marks, 4 mark question you can write very easily, right? Because they will just give the derivations. But to write 1 mark and 2 mark question, it becomes very difficult, right? If you don't believe me, just follow the question paper of previous years. राइट आप पिछले साल का क्वेश्चन पर 5-4 साल 5 साल उठा देखो है कि नहीं है, आपको जो क्वेश्चन लगेगा ना, जो चैप्टर आपने पढ़ चुके हैं ना, आपको उसमें से 3-4 मार्क्स का क्वेश्चन होगा तो आपको इजीली लगेगा. बट द फैक्ट इज दैट द क्वेश्चन ऑफ 1 and 2 marks become very tough for you. Fine. So that's why I'm telling you, for 1 and 2 marks you should prepare very hard. Fine. Please prepare in a proper manner. Okay. Now I shall move to the next topic. Fine. This part is clear, I guess. So our next topic will be electrostatic potential of a system due to 2-point charge. Electrostatic potential energy. I just repeat the word potential energy. This is not just a potential, but this is what? A potential energy, right? So we need to find the potential energy. Fine. Of a system due to 2-point charge. Means we need to find the potential energy of a system, right, where there are how many charges? 2-point charges, right? 2-point charges. So let's draw a diagram first. Let's take a charge. Let's say this is a point of charge plus Q. Fine. Situated at, let's say, this point as P1. I consider this as P1 of a magnitude R1, right? And this will be brought by the charge Q2. I just take this Q1 and Q2 plus Q2, which will be brought from infinity, which we will bring this here. Fine. We will bring this from infinity to at this point. Is it clear? This will be called as P2 and R2. So this is R1, R2. What will the distance between these two? R1. Fine. This will be your R1, 2. Now we will write here. Suppose, or let, you can just write here, let us consider a point charge plus Q1 which is held, or taking a point Q1 at P1 R1. Fine. This is the R1 is nothing but the position vector of point P1. Fine. R1 is the position vector of point P1. I have not shown you that part from point P, point Q again. I have directly written the R1. R1 means what? Position vector of point P1. Fine. Another point charge Q2, or you can write plus Q2, right, is at infinite distance from Q1. Fine. I told you initially this Q2 was at infinity. So we have done some work and bring it at this point. So we need to find the potential energy difference. Fine. We need to find the total potential energy. So that's why we have written this. Is it this part or not? So I get that therefore this P1, P2 is given by what? R1, 2. Right? This P1, P2, I'll likely say this P1 and P2 directly will be what? Nothing but R1, 2. Find this part. Now let's find the electrostatic potential. Right? Let's find the electrostatic potential of Q1. Fine. So electrostatic potential at P P2 due to Q1 on Q2, right? So potential will be created due to Q1 only. On which charge? On Q2. So what is the potential? What will the potential given by point charge? 1 by 4 pi epsilon naught into Q by, what will happen? Q by R12, because this is the total distance, right? And because of this charge we have done some work. From this charge the work is done, right? So it will be Q by R12. Now if I ask what is the total work done, right? So now I'll just write, now total work done equal to what? Total work done on this will be how much? The potential of this means how much it can, what? How much it can attract, or how much work it can do, the potential of this Q1, right? And on which charge we have done this, the 6 Q1. So I can just write that the work done will what? Work done will be nothing but potential, or electric potential you can write, into charge, that is Q2. Fine. Now just put the value. What will get? 1 by 4 pi epsilon naught Q by R12 into Q2. That is what I'll get. This is not cross product, I'm just writing into. So you'll get as Q1 into Q2 by 4 pi epsilon naught into R12. Fine. Is this clear? Is this clear, this part or not? So this is nothing but, again I tell you, this is nothing but what? Nothing but the potential energy. The total work done on the system is nothing but what? The total work done is nothing but your total potential energy. So V is equal to, I can write Q1 Q2 by 4 pi epsilon naught into R12. Fine. So this is our expression for a potential energy, right, due to a 2-point charge. Because of the 2-point charge, the potential energy is given by this. Fine. So this is over. Is it clear, everyone, or not? Oh sorry, this will not be V, this will be U, right? We are finding potential energy, not difference. So it will be U. Potential energy is given by U only, as I have described in the last class also. Now the next, right, this is the last topic basically of the first part of your chapter, right? After this topic we are going to start the second part, that is the capacitance, right? Capacitor and capacitance, that part we are going to start. So now let's start the next topic. So the next topic will be potential energy of a dipole in an external field. Means, what does it mean? Means if you apply an external field on a dipole, right, if you apply an external field, right, or field means what? External force on a dipole, what will be the resultant potential difference, right? Also not difference, potential energy. So let's first draw the diagram. Let us consider this is the electric field. This is a electric field. And I consider two dipole here, like this. Fine. So let's say this is as plus Q, this is as minus Q. So we know this dipole will attract each other, right? So the force will be given to this side and this will be given to this side. Fine. This is nothing but your electric field. Okay. Let's say this makes an angle some theta with the electric field. Fine. Now, what is the force? From this side will be F equal to what? Plus QE, and this will be minus QE. The force will be given by how much? Minus QE. Fine. Is it clear? Because this is electric field, right? So definitely some force they will do on each other, right? They will apply some force on each other. So for this side, this will go this side, and this will go to this side, right? So if the charges are of equal magnitude, the charges are of what? Equal magnitude. So because of that, they are not going to move in this direction or this direction. What they will do? They will try to rotate. Means it will try to rotate like this. This dipole will try to rotate. So if they will rotate, you know what will come? Torque is going to introduced, right? Torque is going to come. So you can just write, let us consider a dipole, these things, introduction part. I guess you can write by yourself, right? Just write the introduction part. So what is the force? Force experienced by the charges. What will get? What will be the force experienced by charges? That is nothing but, you can just write plus minus QE. Aggregation charges means for two charges, one will be plus QE and another will be minus QE. Now the torque acting on these charges, on this or on this dipole, what will be? Right? What will be the torque acting on this dipole? I guess you know. What is the formula for torque? P cross E, right? So if you break this in terms of magnitude, what will get? P E sine of theta. What will get? P E sine of theta. Fine. So it will apply a torque. Now if I apply an external torque, like if I apply the same torque from this side in the opposite direction, right, with the same magnitude, what will happen? What will happen? This will try to rotate like this, right? And that if it was removing, if it was trying to move in a circular, if it was trying to move in a circular direction, what will happen? The external force will cancel each other. The external force, what they will do? They will cancel each other. Means this torque will cancel this torque, so they will remain in the same position, right? So the thing comes about the external torque. Fine. External torque will come. So external torque, as I told you, external torque nothing but with the same magnitude. So now external torque is nothing but PE sine of theta. I will apply the same torque. I will apply the same torque on this, but in a opposite direction. So what will be the work done by me to apply this torque? I need to find the work done by me on this, what? On this dipole. So total work done on the external dipole will be given by how much? W is equal to, if I need total work done, I just need to integrate this, isn't it? So it will look like something like this. And what will be the value of limit? What will be the limit here? Let's say from this is theta 1 and this is theta 2. Fine. So theta 1 and theta 2 I just consider, or I can just take theta naught. That is much better. Right? Just we need to solve this. Is it clear everyone or not? So this will be in terms of what? Theta only. So after integration, what will get? After integration, what will I just integrate it? So after integration, what will get? PE cos of theta naught minus cos of theta. Is it clear? So after integration, we'll get something like this. Now the thing comes, initially if I consider this as theta as to be 90 degree, what is the value? What is the value? If I consider the theta was basically 90 degree, what I will get here? If 90, then what will I get? PE cos of pi by 2 minus cos of theta. So this will be your expression for work done. Fine. And we know if work done is this, then potential energy must be equal to this only. So U will be equal to how much? PE cos of pi by 2 minus cos of theta. So this is your expression for potential energy, fine, of a dipole in an external field. Fine. So this part is over. Now from next class I'll start the second part of the chapter, that is capacitance.